Hi everybody, this is another Unit 4 video. We're going to do a quick Algebra 1 review over how to break down radicals, and then we're going to talk about a new method for solving quadratic equations called the square rooting method. So first of all, a radical is a square root, a cube root, a fourth root. There's lots of different roots, okay? We're going to focus on square roots for now. Okay, but in general, this symbol isn't just a square root symbol, okay? It's actually called a radical symbol because it can be used for multiple types of roots that we'll get to later down the road. I've also listed the first 10 perfect squares, but we may need to go above that to break down some of these if needed. So be aware there's more of these. You just keep on going, okay? Remember, a perfect square is just the number that you get from squaring another number. So when we square 1, we get 1. When we square 2, we get 4. We square 3, we get 9, and so on. That's how I generated the numbers in that list. Now let's talk about how to actually break down some square roots. Okay, some of them are easy. Okay, if you have a perfect square number and you're taking the square root of it, it's very simple. If I take the square root of 225, I just get 15. If I take the square root of 4/9, looks tricky, but really I'm just taking the square root of the numerator, which is 2, and the square root of the denominator, which is 3. So even though it's a fraction, not very hard to take the square root since we had perfect square numbers. But what if we don't have a perfect square number? If I take the square root of 245, I'm going to get a decimal, and I don't want that, okay? So we need to try to break down this square root. And what we want to do is we want to split it into 2 square roots that are multiplying each other. I want to have part of this that's actually a perfect square. So what we're trying to do is we're trying to find the biggest perfect square that is a factor of 245. Okay? So the biggest number that's a factor, or I'm sorry, I should be more specific. The biggest perfect square number that's a factor of 245 is 49. Okay? 49 times 5 gives us 245. So I'm splitting this into the square root of 49 times the square root of 5. Technically, that's still the same as the square root of 245, but what it allows me to do is take the square, or the square root of my perfect square number here, and simplify this to 7 radical 5, or 7 times the square root of 5. So that's what we're trying to do here. We're trying to break down these radicals. So let's do another one here. For this one, we already have a 9 in front of the 45, but we need to break down the square root of 45. So the 9 that's already in front is going to stay there. We're trying to break down the square root of 45, so we need to find the biggest perfect square that's a factor of 45. Okay, it just so happens to be 9. So 9 times 5 gives us 45. But I can take the square root of my 9 to get 3. So I really have this, and then I can multiply the 9 and 3 together to make that a 27 times the square root of 5. Now, the reason we're doing this is because the square rooting method is going to, a lot of times, require you to break down square roots. Okay? Here's the catch, though. Square rooting method's super easy, but it only works if you have a quadratic equation in this format. Okay? You have to be missing the bx part of the standard form for a quadratic equation. Okay? If we have something in this form, all we're going to try to do is get the x squared by itself and then square root it. Okay? Square root both sides. So let's take a look at 2 examples on how to do that. So I told you guys that we have to isolate the x squared first. Remember, that just means get it by itself. Okay? So to do that, I'm going to subtract 8 first, divide by 7, and then take the square root of both sides. If I take the square root of x squared, it's just x. So I take the square root of 1, it's just 1, but we have to be careful. Okay, if I go back to this step right here, okay, x squared equals 1. There are two values that I could plug in for x that make that true. Okay, if I square positive 1, I get 1. If I square negative 1, I also get 1. So anytime we're solving by square rooting and taking the square root, we have to put a plus or minus in front of our number. Okay, so this technically represents two solutions. X can be a positive 1 or a negative 1. Okay, let's look at one more. Again, we're going to start by isolating our variable. So I'm going to subtract 1 first, divide by 8, and then take the square root of both sides. So I get x is equal to, I'm going to put my plus or minus here, and then I don't know what the square root of 2 is. Okay? The other part of this is that I can't break down the square root of 2 like we did in those previous examples because the biggest perfect square that's a factor of 2 is 1, and that's not going to allow me to break down the square root any further. So this is actually simplified as far as it possibly can go, and we have two solutions. Square root of 2 and negative square root of 2. So again, the square rooting method is very easy to use, as you can see here, but it only works if we are missing the bx from the standard form of a quadratic equation. So it's not always going to work. But when you have quadratic equations that look like the ones on the board, it's a very quick and easy method for solving that equation. So let me know if you guys have any questions, and have a great day.